anything, for example, your voice box, where you vibrate your what do you say? Uh, I forgot the exact term, but you basically vibrate to make the sound.
Hmm. Hmm. Okay. What is noise and what is sound? How is noise different from sound?
Noise and sound. Mm.
Do the teachers say don't make sound? They say don't make noise. So what is the difference between noise and sound?
I mean, I thought it was just a proper way to speak English.
No, it has also to do with science also.
I don't know. Oh,
An
wait, one
unpleasant.
second.
Huh?
Yeah,
Whom were you talking to?
my dad called me to remind me to attend class. I told them they don't need to remind me to attend class, but they keep calling me and all.
So you don't attend classes.
What?
To remind you to take class. So what do you do? Sometimes you don't attend class. What do you do in that time?
Sometimes, sometimes the meaning of sometimes is just I take it one time only. Like, if I'm really tired after coming from school, those days I would have a headache in school. So then I would come home and just sleep. The other days I would be fine, like the sinus headache.
Take medication for it.
Mm.
Mm. Okay.
But can you like really cure sinus? Cause isn't like even if I steam like 3 4 times a day, it doesn't go. Cause it just
Sinus is
comes between
something
areas.
which is chronic. Chronic means for a long time. So you cannot
Yeah.
simply get away with it, but you can make your way of life living a little bit better with sinus.
um,
I also had
Like
sinus a few years ago.
yeah.
Hmm.
Well,
Okay, now let's begin.
the sinus, yeah, sinus is like usually it'll be there for 2 3 years, right?
Depends on the reason. There are two types of sinuses. One is allergic, other is non-allergic. And if it is allergic, then you have to stay away from the things which triggers the allergy. If it is
Yeah.
non-allergic, then there can be multiple reasons. So you need to identify what is the core reason of your sinus. It is allergic or non-allergic. If it is allergic, then you need to stay away from those allergens. If it is non-allergic, then you have to see that is there any mucus deposition which you can get removed from the doctor, or you have to see if you have a deviated septum, which you can go and get a corrective surgery. So your sinus will be corrected. So you basically need to visit a
Yeah.
doctor and get to know the exact reason, the cause of your sinus. Accordingly, you can get your medications done and you would find relief.
Yeah, you have to take the surgery only if the sinus is severe, right?
If you take what?
You have to take the surgery only if the sinus is severe, right?
No, surgery is taken when, for example, this is your nose and this is a septum, and that is normal case. But in case your septum is a little deviated, so this side
Yeah.
airflow is less, and then you get developed sinus. So it will remain as it is throughout the life. So in order to, when it is a deviated septum, so you get a corrective surgery, then they just correct your septum like this, and then it's all good.
Mm.
Introduction to sound. Let's take introduction to sound.
Oh.
Hmm. What is sound called in French?
In what?
What is sound called in French? You learned
French.
French as a second language, no?
Yeah, but I can't remember all the words.
Hmm.
Like
You only remember
sound.
bonjour and como ça va.
No, no, not like that. I know a few words. I can like I can introduce myself. I could talk about my friends. Just
Hmm.
basic stuff.
Je t'appelle.
Huh?
See, you don't understand. Anyways, let's get back to the chapter. Introduction to
Oh, I
sound.
can't understand the accent.
Introduction to waves. The sound is produced by vibrating objects. Whatever vibrating objects you have, it can be anything. If you vibrate it, it will produce a sound. Sometimes that it may be audible to us, sometimes it may be inaudible to us, but every vibrating object produces a sound, right? Do you know what is the range in which sorry, yeah. So I was
Yes.
saying, do you know what is the range of human hearing capacity?
No.
It is from 20 hertz to 20,000 hertz. This is the range in which we can hear. That every sound has a range. Let's suppose I say this is a sound and this is a sound. This is of 20
Yes.
hertz and this is of 20,000 hertz. Hertz
Yeah.
is a unit. Like if I say I'm
Yeah.
purchasing something, mass, volume, kg, similarly, sound is measured in hertz. So I say we can hear only from 20 hertz, 20,000 hertz. Like let's suppose this is 20 hertz and this one 20,000 hertz. Let's suppose this one, I say 10 hertz. We cannot hear this. A
We can't
sound,
hear 10 hertz.
huh? No, you cannot.
We can't hear 10. Okay.
So anything which is less than 20 hertz, you cannot listen it. Anything more than 20,000 hertz, you cannot listen it. Now you would say I can hear any loud sound. So if you would hear anything more than 20,000 hertz, your eardrums would burst,
Yeah, exactly.
right? This is the normal hearing range for human beings. Or sometimes some
Hmm.
objects vibrate, but the vibration produces a sound less than 20 hertz, which we cannot hear. You must have heard about crickets.
No.
Crickets, small insects in the rainy
Yeah.
season. They so what they do, if you must have seen a cricket, they have wings, right? And what they do, they like if these are the wings, they rub their wings, and that rubbing of wings it produces a sound which is of so loud decibel that it sometimes irritates us, right? So
Yeah.
see such a small insect just by touching or rubbing its two wings, it can produce such a loud sound.
Oh, that's how it creates sound.
Yeah, that is how sound
Oh.
is created. When they rub their wings when to their body, it produces that irritating sound.
Uh,
The sound is produced a very big highlighter. The sound is this is also big. Okay, so I told you that vibrating objects produce sound. They travel from one place to another in the form of waves. Now, how does this sound travel? Let's suppose I am speaking here. How are you listening? Because my voice is going to um, the speaker of this laptop, and from there, you it is getting displayed to you. Or even it would have been in front of you. So, like I am speaking at a distance, you are listening at a distance. So there is some distance between us. So how
yeah.
is sound traveling? Let's suppose this is a guitar vibration. So its wires when you vibrate them, it produces sound. And that sound is traveling all the way to this guy whose name is Rohan. So that sound is traveling to this guy. And how is it traveled? How does sound travel? First of all, sound travels only in air.
Yeah.
So which means that we're on the planet Earth, and here we are surrounded by air. So that you can listen to me. Like how do I see that my sound is reaching you if you're sitting in front of me? So air
Wait.
is, huh?
Can the sound waves go through like walls?
Yes, they can,
Oh,
but it would be very light. Suppose imagine I am speaking something in front of you sitting. You can hear it very easily. But someone
yeah.
sitting in the next room speaking, so you would only listen to the very blur sound of that person. You would listen but not able
Yeah.
to understand it.
Yeah.
Now, air is present, and that air is the medium which carries that sound from one place to another. And sound travels in the form of waves. This is very important point. That
Yeah.
in what form does sound travels? It travels in the form of waves. And what are the waves? Waves are like this.
Yeah.
Hmm.
Well, how do they know it's like that?
Science has proved, experiments have proved.
Uh,
Hence the name. We also called it sound waves.
Wait, like how can you capture something invisible?
How can you know that air is present? How do you know? It is also invisible. But our science is very
Uh,
evolved. Experiments have been done. If you take science,
mm,
you will get to know. If you don't, then forget it.
oh,
Mhm. So see this guitar. If the strings are vibrated of the guitar, it produces a sound. Right?
yeah.
Waves and particle motion of waves. So what is okay? When I talk about wave, we also talk about particle motion. That particles also move, particles also vibrate. That we're gonna study about waves and also the particle motion.
Mm.
Mechanical waves are the waves that travel through a material medium. So here we are talking about what kind of waves? Mechanical waves. What kind of waves we talking about?
Mechanical waves.
Mechanical waves. Okay. And mechanical waves need a medium to travel. Can you give me an example of mechanical waves?
No, I don't know.
Are you that dumb?
Yeah, I mean,
I'm
this
saying
is the first time I'm seeing
mechanical,
some.
listen to me.
Yeah.
Mechanical waves are the waves which need a medium to travel. Now, can you name me any such wave?
Uh,
Just now I told you sound is a wave which needs medium to travel. Just now, few seconds ago.
oh,
What? You didn't
yeah.
get it.
No.
I'm saying I said that mechanical waves are some sort of waves which need a
Yeah.
medium to travel. When they want to travel, they need a medium for that. And did I not tell you just a few seconds ago that sound can only travel, sound is a wave and it can travel only through air. So it needs a medium, so air is the medium. So an example of mechanical wave is sound wave. Huh?
Oh, yeah, yeah,
Got it?
yeah.
Hmm. So now you can see that sound wave is a mechanical wave, is an example of mechanical wave.
Sound wave.
Hmm. What are mechanical waves?
Mechanical waves are the waves which can travel only through a medium.
Yes. So which means example sound wave. Sound wave needs
Yes.
a medium to travel. They need air to travel. They need solid to travel. They need liquid
Yeah.
to travel.
Mm.
No,
Sound waves can go through anywhere, right?
yeah, but they need a medium, be it
Yeah.
solid, be it liquid, be it air.
Okay.
Now you tell me, in which medium will the sound travel the most, and in which will it travel the least? Hmm?
It'll travel the most in air,
Okay.
and least should be solid objects.
Hmm. This proves that your science is weak
Huh?
because did you not study in atoms and molecules that in
Mm.
solid the molecules are tightly packed
Yeah,
and in air the molecules are scattered?
exactly.
So if I produce sound here, the sound waves can move in continuity. They have no gap. So it will move faster. Like suppose you have a road in which the bricks are joined. You can move easily. Now there is a road where bricks are kept like this. You have to be cautious to step on each brick. Now here, sound will travel here, then there is gap, then it will travel here, then it is gap, then travel here. So it will take time to travel here. And so we said that sound travels the most in solid and the most fastest in solid and the slowest in air.
Oh,
Understood the logic?
yeah.
Why? Why sound travels the fastest in solid?
Because the molecules in the solid are tightly packed, which
Hmm.
makes it easy for the sound waves to pass, just, keep going, you know.
You can say that the sound wave can travel faster because
Yeah,
the energy can be transferred very quickly to the next molecule. The sound wave can be
yeah.
transferred to the next molecule very quickly because they are joined together and closely packed.
Hmm.
That is why you must have seen that. Um, I mean, the children in the villages they used to do that. Like, let's suppose this is a railway track. So if you lay
Hmm.
down and put your ear on one of the railway track, so you can hear the train coming even if it's kilometers away because
Uh,
sound travels the fastest in solid because train is moving on
oh,
these tracks and so you're putting your ear. Also you must have seen that if you do head down and your ear is facing the table, you make a little sound tuck.
yeah, I know. I know.
It feels like very big sound. That is because sound travels the fastest in solid, and you make the same tuck sound on the table with keeping your head up. You would not feel it that hard, that strong, right?
Yeah.
Hmm. Okay.
Hmm.
Mechanical waves. Mechanical waves are the waves that travel through a medium. An example would be sound wave.
Sound, air.
Hmm. Now, uh,
Sound or liquid. Can I say liquid and solid?
what solid liquid?
Uh, uh, Examples of mechanical waves.
Liquid wave. What is liquid wave? Have I written air wave here? I've written
You said liquid.
what liquid?
Liquid as a medium.
Liquid has a medium.
No, liquid
Liquid
is the
is
medium.
a medium.
Yeah.
So
Oh, oh, okay. Okay. I understand. I understand.
I was saying that this is sun and this is earth, and sunlight travels from all the way from sun and reaches earth, right?
Yeah.
Now you know that there is no air in the space.
Yeah. Oh,
Sunlight the sunlight is called the waves of the sunlight. It is called IR wave.
IR waves. Oh,
Yeah.
God.
So now you see these waves, they are traveling from means they are originating from sun and they are reaching the planet Earth, and there is no medium between sun and Earth.
Yeah.
So such kind of, so you can say that IR waves are non-mechanical waves.
So light needs a medium.
Light does not need a medium to travel. Yeah. That is why it is reaching from sun to planet Earth.
Oh,
If it
okay.
would have been needed a medium, then we would have not
Yeah,
received sunlight because there is no air between in the space.
correct.
Light does not need a medium to travel, but light gets blocked by a medium.
Yeah.
Both things are different.
Yes.
Mechanical waves which need a medium to travel and non-mechanical waves which do not need a medium to travel. Example of mechanical waves, you can say sound waves, right?
Yeah.
Now, mechanical waves are of two types, right? They are called transverse waves and longitudinal waves. What are the two types of mechanical waves?
Transversal and longitudinal.
Longitudinal and transverse. Now, which one of
Yeah.
these needs a medium to travel and which one doesn't?
Uh, am I supposed to know that?
Answer me. Which one needs a medium to travel and which one doesn't?
Mm, the transversal doesn't need a medium.
Why? Can you give me explanation?
I don't know. I was guessing.
And you guess what? I know that you would give me wrong answer only. That's why I asked you because it's very easy to manipulate you. What did I tell you in the starting? Transverse and longitudinal are both example of mechanical waves. So both needs medium to travel.
Oh, but when did you say that it's the examples of that?
Yeah, what you do after this lecture, go and see the recorded lecture. Then you will get to know when did I say that. I said it
Okay.
twice. Okay.
Yeah. Yeah.
Hmm. So transverse and longitudinal waves are both example of or other types of mechanical waves. They are the type of mechanical waves. So definitely if they are type of mechanical waves, both are mechanical waves. So both need a medium to travel. Transverse
Mm,
waves travel transverse in a transverse manner and longitudinal waves travel in a longitudinal manner, which we'll see later, right?
yeah.
Now it is of two types, transverse and longitudinal. Now how, like why have we made two types? What was the basis to segregate them? So it depends on the direction of motion of the particles, which I just told you, right? Both are mechanical
Yeah.
waves, both need a medium to travel. The only difference between both of them is that direction, like there is wave. In the waves, particles are there, right? Now,
Yeah.
how these particles travel, on that way we have differentiated both of them. In transverse waves, the particles move differently. In longitudinal waves, the particles move differently, which we'll see later.
Mm.
Tell me, what are mechanical waves?
Mechanical waves are the waves which can only travel through a material medium.
And what are the two types of mechanical waves?
Two types of mechanical waves are transversal and longitudinal.
Okay. Uh, they are differentiated on the basis of
Uh, the way the particle moves.
on the basis of the movement of particle in the medium, right? So
Yes.
we see
Yeah.
that on the depending on the direction of motion of what? Of the particle of the medium and the wave propagation. So simply they are just written in a very fancy language. So reading that, the direction of motion in which direction is the particle, moving, and particle of whose particle? A particle of the medium. And the wave propagation. What do they mean by wave propagation? Simply the the direction in which particle will move, in that direction wave will also move, because wave is made up of particles. Got it?
Yeah. Yeah.
Hmm. Now let's do some writing work. Did you get a new copy for both science and maths?
No, I forgot.
Every other student does it in a different copy. Only you do it in the same copy.
Hmm.
Put the heading introduction to waves. First point, second point. Write this.
Hmm. Introduction to sound and waves, right?
Hmm. Introduction to
Okay.
waves. Um,
Oh,
don't write waves, write sound waves. Introduction to sound waves.
okay.
Hmm. Hmm.
Yeah, done.
Put this heading. Write it as a first point. Only write first point. Second point I'll tell you.
Okay. Yeah, the second point.
Right. Mechanical waves are of two types.
Mechanical.
Mechanical waves are of two types.
Yeah.
Depending on the direction of depending on the direction of
on the direction of
motion of the particle of the medium, motion of the particle
particle
of the medium,
of the medium
and the wave
and the wave
propagation.
propagation. Yeah,
Hmm. Right? The two types are
the two types are
number one, transverse,
transverse,
number two, longitudinal.
longitudinal.
Hmm.
Yeah,
Put the heading transverse waves.
okay. Yes,
One second. Particle motion is through. Is to perpendicular, not is to perpendicular to the direction of wave motion. This type of wave is a mechanical wave called a transverse wave. For example, light or even Mexican wave. Okay, write these 3 points in transverse waves. Okay, first you write, then we'll see what it is. One, two, three, and please highlight this word perpendicular.
okay. What is a light wave?
Where have I written light medium?
Huh?
Where is written light medium?
I didn't say light media, I said light wave.
The wave of light, sunlight. No, not sunlight.
It doesn't.
Other light, light wave.
Wait, so I thought light doesn't need a medium.
No, that is not sunlight. It's only normal light.
Okay. Uh,
One
should I write the
second.
longitude?
No, wait.
Oh, okay.
In this, you write one example also. Example: light wave and Mexican wave in a sports medium. In a sports stadium. Mexican wave in a sports stadium.
What? Mexican wave in a sports
Mexican
stadium.
wave
Yeah,
in a
I got
sports
that.
stadium.
Mexican wave in a sports stadium.
Written
What's a Mexican wave in a sports stadium?
a type of wave. Particular.
Name.
Right. Put the heading longitudinal wave. This goes to point number. Sorry. This was point number one, two, and three.
How does the ultrasound work?
Ultrasound wave.
Yeah, like
People get
uh,
ultrasound, huh? That have you seen how people get ultrasound? First of all, you know what is ultrasound?
uh is that thing where they put the gel on your stomach, right?
Yeah. And then they put a
Uh,
machine, and that machine sends waves which go inside your stomach and produce an image of what is inside. So those waves are called ultrasound waves, which produced by that machine. It's called ultrasound machine.
so what's the medium in that?
Your stomach, your liquid inside the stomach, your organs. It is not traveling. First of all, it's traveling through solid medium. Your stomach is there, your skin is there, your flesh is there, your tissue is there, your organs are there. That is the medium for it to travel.
Uh, okay.
Now, in transverse wave, you make this diagram. Which
So
one?
I should draw it?
Yes. This diagram. Put the heading transverse waves and make this diagram.
Okay.
You can make it up till here only. I mean, till here only. Need not to make extra, because it's understood. You can make up till here.
Oh,
Yeah. Please make the diagram neatly, okay?
oh,
Make the arrows properly.
mm. Oh, yeah.
Okay, first you look here. First you look here. Okay, so
Yeah.
now you see this, they are saying that this is a transverse wave, right? A transverse wave. So this is basically, see, the wave is like this, and it
Mm.
would be again like this. Can you see the wave here? This is the wave like this. Okay, the wave is like this. They've only showed a little part of that wave. Okay, the wave is like this. Now in this wave, I told you there are particles. So see, these red ones are the particles. This is a particle. This is a particle. This is a particle. So these are all particles. Okay.
Oh,
Yeah, these red ones are the particle. They have mentioned particle movement. They have made arrows. So which means in this wave, right? I talk about particles. Let's take a particle here. Let's take a particle here. Let's take a particle here. Now they say that, now what is the name of the wave? Transverse wave. The transverse wave means that the particle will move up and down like this. You see this particle. Now how will the particles move? This particle will try to come down and this particle will try to go up. So what would happen
okay.
when this particle will try to go up? So if okay, I'll explain it to you here. Let's suppose this is a wave and one particle is here and one particle is here. Okay, particles are everywhere. I'm just taking few particles. Okay, particles like here, everywhere particle is there, but I've taken just few particles. Now, since this particle is at the highest position, so it will try to come down, and this particle is at the lowest position, so it will try to go up. Now, what would happen when this particle will go up? So for a very, very, very short period of time, a straight line would be created. Why? Because this particle has gone up, it would reach here, and this part, like, because you see, na, if it will go up, it will come here. If it comes down, it will come here. So a straight line would be created, right? So for a second, this will be created, but we don't show this because it is for a very short period of time. So we would show after what would happen this. So after this, because this particle is trying to go up, so for a short period it will come here and then it will go here. And now this particle was
Mm.
here only. And this particle which was trying to come down, first it will be here, then it will be here. So what are the new positions of particle? This particle has moved. This is also, he has moved. This is moved. This is also moved. Now this is what we get. So now this is what the wave has become. That is why waves keep on changing their shape. and that is how they move forward. Understood?
Yeah.
So how is the wave moving forward? Particles are doing motion. What kind of motion? Transverse motion. What is transverse motion? Up and down motion is called transverse motion. Understood?
Uh, okay.
Hmm. So you see here, particles are doing up and down motion. So you see this particle is trying to come down, and when it comes down, then again it will try to go up. The particles keep on doing that. A
Mm.
particle which is up, it will come down. If it is down, it is goes up. So it keeps on going, right? So if particle goes up and down in a wave, particles goes up and down. Okay. So where will the wave move? Wave will move forward.
Yeah.
Have you have
Oh.
you have you done this? Like childrens do it. Sometimes what they do, like whatever moms wear na, as a piece of dupatta, it is called. Like if you must have taken a piece of long cloth and you have done it like this in childhood, no?
Yeah.
So if you
Yeah.
take a piece of cloth and you just shake it like this, so what it does, it forms waves, right?
Uh,
So if particles move, so this question can also come that if particles are moving up and down in transverse wave, so that the wave will move forward. See, direction of wave will move forward, and particles, where will the particles move in transverse wave? Up and down. Okay,
yeah. Upper.
right here, particle movement up and down.
What?
Okay,
Mm.
make this fast.
Yeah, I drew it.
Complete.
Yeah, but like, what is the thing in between, like the chain?
Those are other particles which we haven't mentioned. I told you, know, the wave is more made up of continuous particle. So this particle we made red just to highlight its motion, right? This is also a particle, then here is a particle, then here is a particle, then here. So many particles are there. But if they would have made all red particles, you would have got confused, no? That which particle moves where. So they have just highlighted a few particles with red, and the others are also particles of the wave. Understood?
Yes.
Now
Yeah.
make the longitudinal wave. Before making it, you can first see in here what happens. In transverse waves, particles were moving up and down. But in the longitudinal wave, the particles move left and right. So you see this is a long
Yeah.
wave, and these are all are particles. These are also particles, and these are also particles. Black ones also. But we're talking about a few specific particles, like take the red ones. So here, this particle goes here, and this particle goes here. Now, okay, have you seen a spring?
Yeah.
So let's assume this is a spring, long spring. I am holding the two ends of a spring, right? If I stretch, and
Yeah.
let's suppose those are the two particles, okay? If I stretch the spring would feel like loosed, right? And
Yeah.
if I bring the points, let's suppose I am playing with the particles. The particles are at the end of the spring. If I take them apart, so it would feel like it is stretched. And if I bring them close, so you would feel that the spring has compressed. Then definitely, if you will take the particles apart, so what would happen? The spring would look like this. And if I bring the particles close, the spring would look like this, right?
Yeah.
Hmm. So this happens when then the particle movement is left and right. And left and right, we don't say left and right in science, we say to and fro. So here particle
Yeah.
movement was up and down, and here particle movement is to and fro. Right? Make this. Are you using two different pens
Yeah,
to highlight a particle motion?
yeah, yeah.
Mm.
Marker actually.
Whatever.
Yeah, done.
Okay. So now you know that in a transverse wave, particles move up and down, and in a longitudinal wave, the particles move to and fro. And that is how
Yeah,
but you see, whatever way the particle moves, it goes up and down, it goes to and fro, the wave moves forward.
yeah.
Sound properties we'll do in the next lecture. Okay.
Okay.
Okay. Right.
Okay. Bye, sir. Good night.
Night.